Hello math learners, welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the 5 laws of radicals. If you don't know about these 5 laws, then I suggest you sit back, relax, and finish this video. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 9 mathematics, which is all about the law of radicals. The question is, what are the law of radicals? There are 5 laws of radicals, and these are the 5 notations as you can see. The first one says the nth root of a to the power of n, which is just equal to the quantity of nth root of a to the power of n, will be equal to a. Example of that is if you have a cube root of x cubed, well, basically what you can do is the answer automatically is x. Why? Because you can automatically cancel the 3 here and the exponent of 3 in this one. Basically, if you change this into the exponential form, this will give you x cubed to the power of 1/3, which is just the same as x to the power of 3 over 3, and if you simplify it, the answer is x. Easy, right? Now, let's go to the second law. We have the nth root of a times the nth root of b is just the same as the nth root of a and b. Example, if you have square root of 3 times square root of 27, then that is just the same as the square root of 81. And if you simplify the square root of 81, you can have plus negative 9 or just 9 as its principal root. Easy, right? Now, let us go to the third example. We have the nth root of a over b is just equal to the nth root of a divided by the nth root of b. Now, what does that mean? Example, if you have the cube root of 32x to the power of 7 divided by the cube root of 4x to the 4th, it is just the same concept as to you get the cube root of 32x to the 7th over 4x to the 4th. Now, in this case, you can simplify this one, and this will become the cube root of 8, because 32 divided by 4 is 8. Then x to the 7th and x to the 4th, if you subtract 7 minus 4, that will give you x cubed. Now remember that 8 is a perfect cube, and the cube root of 8 is positive 2. And then, the cube root of x cubed is just the same as this one, so basically the answer is x. So finally, you have your final answer as 2x. Easy, right? Now let us go to the fourth rule. The nth root of the mth root of a is just the same as the product of mn root of a. What does that mean? For example, if we have the square root of 81, then that is the same as the fourth root of 81. Okay? Why is that so? Because there is an index of 2 here and another index of 2 here. So multiplying the 2 indices, that will give you 4. Now the question is there a fourth root of 81? So if you get the prime factorization of 81, that will give you 3 to the power of 4. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. And since this is an example of our first rule, then we can have an answer that is 3. Easy, right? And now let us go to the final law, that is the rationalization. Now, in terms of radicals, your final answer must not have a radical sign in the denominator side. Therefore, if you have a problem like this, 1 over 6m, then you can apply your third rule, which is square root of 1 over square root of 6m. If you simplify this, the square root of 1 is 1, and in the denominator side is still the square root of 6m, because 6 is not a perfect square and m is not a perfect square. However, is this kind of final answer acceptable? My dear math learners, it's not. Why? Because this given expression has a denominator that has a radical sign. So if that's the case, then you need to apply the fifth rule, which is the rationalization. Now, what is rationalization? You will try to eliminate the radical sign in the denominator side. So how would you do that? What you can do is you can multiply both the numerator and denominator by the needed expression for 6m to become a perfect square. Now, 6. What is needed of 6 to become a perfect square? So, basically, that is 36. So, 6 should become 36 in order to become a perfect square. So, what should be multiplied to 6 in order for this to become 36? Then that is square root of 6. Of course, if you multiply square root of 6 in the denominator side, you also multiply square root of 6 in the numerator side. However, we still have our m. M here has a degree of 1. Now, in order for it to become a perfect square, what is the minimum requirement of m to become a perfect square? Then, it needs another m to become m squared. So, we need to multiply another m so that if you multiply this 2, this will give you 1 times the square root of 6m for the numerator, and 6 times 6, that is 36, m times m, that is m squared. Now, having this, you can simplify 1 times square root of 6m into square root of 6m over, what is the square root of 36? That is 6. What is the square root of m squared? That is m. And this is your final answer. You have an expression without a radical sign in the denominator side. And that is what you call rationalization. Easy, right? Now, let us have some series of exercises for us to apply this concept. Okay, math learners, we have here our exercises for us to clearly understand the law of radicals. We have here the first problem, square root of 5 squared. Now, this is an example of the first law having the same index and the same exponent. What you can do is you can cancel the index and the exponent, and that will give you 5. Easy, right? Now, let's go to question number 2. What is the square root of 3 times the square root of 8? This will give you 8 times 3, that is 24. However, square root of 24 can be simplified. How do we simplify this one? You can break it down to its factor, in which one factor is a perfect square. So what are the factors of 24 in which one factor is a perfect square? That is square root of 4 times square root of 6. Always remember to write first the perfect square. So what is the square root of 4? That is 2. What is the square root of 6? We don't have any, so we just copy it, giving us our final answer as 2 square root of 6. Easy, right? Now, let's go to our third example. What is the cube root of 128 divided by the cube root of 2? This is an example of the third rule. And what we can do is we can take them as one radical sign. And we have 128 divided by 2. We can simplify 128 by 2. So that is 64. So the cube root of 64. Now, is there a number that can be multiplied 3 times to itself? The answer is 64. There is. And that number is positive 4. Because 4 times 4 is 16. And 16 times 4 is 64. Easy, right? Now, let us go to our fourth example. We have the cube root of 40 over 5. Now, of course, 40 over 5 can be simplified. So, 40 divided by 5, that will give you the cube root of 8. Now, 8 is a perfect cube. And the cube root of 8 is positive 2. Because 2 times 2 times 2 is equal to positive 8. Easy, right? Now, let us go to our fifth example or fifth problem. The square root of the cube root of 64. Now, remember, this is an example of our law number 4. So, if that's the case, the index of the square root is 2. The index of the cube root is 3. So, 2 times 3, that is 6. So, that will give you 6th root of 64. Now, the question is there a 6th root of 64? Now, if you try the prime factorization, you will have the 6th root of 2 to the power of 6, which is now the same as our first law, and the answer is 2. Easy, right? And now let's go to our final example. We have here the square root of 4 over 5x. Now, if this is the case, you can have the square root of 4 and you can have the square root of 5x. However, the square root of 4 is 2, but the square root of 5x is not a perfect square, so you just have square root of 5x. Now, is this the final answer? Not yet, because we have an expression that has a radical sign in the denominator side. So, if that is the case, you will multiply the whole fraction to its denominator. So, in this case, I will multiply both the numerator and the denominator by 5x. Why? Because 5 needs a 5 to become 25, which is a perfect square. X need an x to become x squared in order for it also to become a perfect square. So that will give me 2 square root of 5x, because 2 times square root of 5x is 2 square root of 5x, over square root of 5 times square root of 5, that is square root of 25. X times x, that will give me x squared. Finally, I have a final answer of 2 square root of 5x over, what is the square root of 25? That is 5. What is the square root of x squared? That is x. And this is my final answer. Easy, right? So I hope you have understood the different law of radicals and its application. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time about our topic for today. This is still your free access math teacher Ash, and always remember, it is fun to learn mathematics if we are together learning. Thank you so much for subscribing, liking this video, and sharing this to your fellow friends, classmates, and schoolmates. Take care, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.